Okay, so continuing on with class 10, I decided to add this example from Hibbeler, because this is sort of a basic thing that we should be thinking of, a basic concept in impulse and momentum, is the idea that we're going to integrate the force times time, right? And so the integration will result in, when we have a plot, of force versus time, integrating it will be the area underneath the curve. So in place of the thing that says the integral of f dt, we can just put in the area that we find from a plot. So that's a basic type of problem, and they don't really cover it, I don't think, or they don't emphasize it enough. Or some of my other examples didn't used to have it in there. So that's why I added this thing in, I think, last year, right? So it's just a basic problem where we have, force and time right here. So what I'm saying is right here is that right there, that force equals the area in a force versus time curve right here. So we have a 40 kilogram block right here is moving downward at 10 meters per second, and the motor pulls on the cable with a force of F, which has a magnitude that varies as shown on the graph. We want to find the speed of the crate when t equals 6 seconds right here, right? So we're assuming that they mean that the thing is moving at 10 meters per second at time equals 0 right here. So we draw out our three diagrams here. So we have initial, we have impulse, and then we have final. I don't know why I always put final in caps. And we go X and Y. So this one right here is initially it's going mv1 and it's going downwards, right? And this thing has two cables pulling on it, right? We could cut the cables apart right there. You can see that it has there. So it's going to be 2 times ft delta t. Well, or we say 2 times the amount of that tension, right? That F that's up above. And we want to integrate that right there. And I just said delta t. Not true. Integral f dt right there, and maybe I'll write in I'll say it's tension. Okay, and then this also has the integral of w dt right there, but that's really, we could just say that that's going to be delta t, right? Because this weight is constant. This force is not constant. The force is changing with time, obviously. So and then we also have this mass times the well, we don't necessarily know. We don't necessarily know that this thing is going to go back upwards, but I guess I decided to assume that it was. Right? This thing is pulling, so usually it's going downwards. So we don't know. So maybe it's best that we assume that it's going upwards right here at the second time. All right. So I decided, why did I decide to put that down there? I don't know. I think I'm going to write down mass velocity 1 plus imp 1 to 2 is equal to mass velocity 2 right in there. And so I will say, okay, so first off, the mass times velocity, it's going to be 40 kilograms times 10 meters per second, but it's downwards. So I'm going to make sure that it's negative right there. And then we want to try to do all of this work right here. Not work, it's not work, but we want to do the effort to solve these things. And I will find the area right? That's going to be times that right there. Okay, so this impulse is going to be this part right here, and so that's going to be 2 times, and so we have a trapezoid, right? So that's going to be the formula for that is 1/2 times this 150 plus 450, right? So we're going to get like the average of those two. 150 plus 450 times the amount of time, right? 0 to 6, right? So that's going to be times 6. And that's a positive impulse coming upwards, right? Whereas the others is going to be a negative, right? Because it's going to be the 40 times our 9.81 times our delta 6 right here, right? So that's this guy. And that's going to be equal to 40 times whatever this ends up being. And mind you, this is in the y direction right there. I mean, we're making that distinction because later on we'll see that we need to make sure that we're keeping track of the x and the y. So, looking through there, I think, oh, and by the way, if you wanted values into all of this, this is like 3,600 Newton seconds, whereas this right here is negative 2,354 Newton seconds. So you can see what the influence of that's going to be. We get V2 is going to be equal to 21.15 meters per second up. And it does turn out to be positive, so that thing that we guessed over here was correct. If we had chosen negative, we would have found that was a negative answer, and then we would have been like, oh, that was dumb. Yeah, but you could see that this turns out to be 400, negative 400, so that this ends up being a positive value right in there. So the important point here is that, you know, this integral thing, this thing is integrated right here, that impulse, and we can integrate by finding the area. So that's a pretty common problem that you'll see in impulse and momentum.